Hey everybody, this is just a quick review on multiplying polynomials. And one of the reasons I want to do this right now is that pretty soon we're going to start working on factoring. Factoring is really simply division. So in order to get ready to factor quadratics, I just want to work on multiplying quadratics. All right, so you can see the learning targets there. We're going to be talking about polynomials, what is a polynomial, what's not a polynomial, etc. Okay, so I took both of these images from Math is Fun, but I thought they were great because they really showed what's going on. So right here you have an example of a polynomial that has 4 terms in it. The first one is 5xy squared, the second one is negative 3x, third one is 5y cubed, and the last one is negative 3. Terms in polynomials are separated by addition and subtraction signs. Okay, now you might say, yeah, but Ms. Bailey, you called that a negative. Yeah, I did. You can think about it in both ways. If I were saying this all together, I would say 5xy squared minus 3x plus 5y cubed minus 3. But when I'm thinking about the terms separately, I do think about them as negatives and positives. And there's no problem there. It all means the same thing. It's easier when combining like terms to think about this, for example, as a negative 3x. Over here, you see a couple of examples that are not polynomials. And that is because you cannot have a variable in the denominator. In this one, it's like, yeah, well, it's all in the numerator here, but remember with our work with negative exponents, this is really the same as 1 over y squared. So if there is a negative exponent, I want you to consider that it's actually in the denominator. So this is one reason we've been working on expressing terms with no negative exponents. All right, so these two are not polynomials. Basically, it just means that the variable with the exponent always needs to be in the numerator. All right, there are 3 major terms that we use for polynomials, and really this just has to do with how many terms they have. So a monomial has 1 term, binomial 2, trinomial 3, and just think about the prefixes on cycles. A monocycle, sometimes called a unicycle, has just 1 wheel, bicycle 2, tricycle 3. They also explain there's a quadrinomial and quintinomial. Those terms are not used that much though. Right, all of these can be referred to as polynomials, and poly is just a word for many. So anytime we're talking about a polynomial, we really don't know how many terms we're talking about, which is why sometimes we use the 3 specific terms there. Okay, I want to review multiplying a little bit here. So the first one will be a monomial times a trinomial. What you really need to remember is that you need to use the distributive property and the appropriate exponent rules. We'll also be combining like terms when needed at the end. All right, so if you look at this, I did 2x times 3x squared, right? And that gives me the first term, 6x cubed. So you start by multiplying the numbers, 2 times 3, and then use your exponent rules for multiplying with the variables here. So 1 plus 2 is 3, so 6x cubed. Second term, 2 times 4 is 8, x squared. Last term, negative 14x. So this is your final answer here. I mentioned we're going to go to factoring next. When we're factoring polynomials, we actually go from this back to the beginning. So when we're factoring, it's like dividing, right? That's all I'm going to say about that. Let's take a look at this though. Earlier in the year, we worked with something called generic rectangles, right? By the way, this should all be a review for you. I'm hoping you remember this. This is often referred to as the area model as well, where our length and width are shown as 2x times 3x squared plus 4x minus 7. Each square here is the length times just the width of that square. So we split it up into 3 sections. And this actually would be the area of that inner rectangle if the dimensions were 2x and 3x squared plus 4x minus 7. I'm hoping you can see how the area model or the generic rectangles actually match the answer above. We will be using generic rectangles to help us visualize factoring as well. Okay, here's the binomial times a binomial. And again, you're going to use distributive property. What we're going to do though is distribute the x to both terms here and then distribute the 5 to both terms. So since we have two terms here, we have to distribute both of them. All right, so x times 2x is 2x squared. X times negative 3 is negative 3x. 5 times 2x is 10x, and 5 times negative 3 is negative 15. There you have it. We do need to do one last step here, though. If you can combine like terms, you should do so. And so you can see we can combine the negative 3x and the 10x to get positive 7x. Here's the generic rectangle for that. And again, I hope that makes sense. So x times 2x right here, x times negative 3 here, etc. All right, so take a look at that and just see how that matches. And of course, in the generic rectangle, we have not combined like terms. All right, I just wanted to remind you of this. I think we talked about this before. Whenever you have a binomial times a binomial, there is something called a mnemonic device. So down here, you can see a mnemonic device is just a way to remember something. And that is referred to as FOIL. F stands for first, O stands for outers, I is inners, and L is last. And it says in that box that this is really not a principle of mathematics, it's just a way to remember. So if you look here, your x and your 2x are the firsts. So that's what we did when we distributed the x here. Outers are the ones on the outside, so x times negative 3, so that was what we got when we distributed the x. Inners are these two on the inside, and then lasts are the two last terms, the 5 and the negative 3. I really prefer that you just think about it as distributive property because that is the correct mathematical concept, but every now and then you hear people talk about FOIL. Have you learned FOIL yet in algebra? All right, well, you just did, okay? Let's take a look at the next one here. So this is a binomial times a trinomial. Same, okay, use the distributive property. All right, so you're going to distribute 2x to each of these, and then 5 to each of these, then combine like terms. So you can see when I distributed the 2x, I got 6x cubed minus 4x squared plus 8x. Then when I distributed the 5, I got 15x squared minus 10x plus 20. And then in terms of combining like terms, we combined the negative 4x and the positive 15x. That gave us positive 9x squared. And then the 8x and the negative 10x gave us negative 2x. All right, so this is your final answer right here. Here's the generic rectangle for that. One thing that helps me is if I think about the generic rectangle, I remember when I'm multiplying them initially, I should have 6 terms, 2 times 3. So that's one thing that I often visualize when I'm doing this step. And again, you can see we have not combined like terms here. But I just wanted to remind you about the generic rectangles because we'll be using them later. Okay, so what I'd like you to do is try these 3 on your own. So just pause, do these 3, and this is really the only piece of writing that I'm going to expect you to do from this. And once you have finished, just check them on the next slide. All right, and here they are. I hope you took some time to do it yourself. And if you got any of the answers wrong, I just want you to double check and see what happened. And of course, if you are stuck at all, just send me an email and just say, I really don't know how to do this, and I'll set up a time to meet with you on Google Meets. All right, that's it, and I hope you have a good day.